let's start very briefly with admin things or logistics things of the course. Please remember that the test is this Saturday at noon. I still sometimes this question where the syllabus is or course outline. Well, we spent the whole first lecture on that. So it's the slides of lecture 1, where you also can find all the dates of the assignments and all the assignments and tests. So this Saturday at noon, from noon to 1:30, we have a test, as you know, first one. It's worth 11% of your grade. So it's going to be like an assignment. It's going to be posted available on Brightspace on noon. And then just like your assignment, you submit whatever you're required to submit at 1:30. So I still haven't made a test, so I'm going to communicate. I'm going to send an announcement, so keep an eye on your announcement with a little bit more information about it, but basically expect something like what you have for your assignments. It may have a couple of questions that are multiple choice, testing your, like those tasks that you have in lab, the type of questions. But the main part of it, the main points will come from coding. So you will code and submit your code the same way you do for your assignments. So for example, you will be told submit a file test1.py to Brightspace, and it's going to contain answer to coding answers for your questions, and you can expect, and the type of the question will be write a function that does blah, right? The same way you had to do in assignment number 1 and assignment number 2 and in your labs. The material that will be covered is everything up to today, so not including today. So today we are going to do loops over strings, indexing of strings and stuff, solving problems. Well, our first problem with a loop on strings and so on. So that is the plan today. So what you're going to see on the test is everything up to today. So assignment 1, assignment 2 material, if statements, and lab 1, 2, and lab from this week, lab 3. No turtles. So the point of the turtle question in assignment number 1 is I wanted you to do a question where you do background work yourself, where you learn about the library, you see what functions they have, and you make something out of it. But we are done with them. You won't have to, so you don't really have to know anything else about turtle. You won't be seeing it anymore. So everything up to today is a fair game, may appear on your test, and it will, I forgot, I lost my train of thought. In either case, all of these things will be on your test, excluding turtle. You're certainly not going to see turtle. So the format is going to be like your assignment. It's going to appear as test 1. You download it, you read it, you code your answers, and you submit it. If there are theoretical questions, let's say there's a multiple choice question, you will just, inside of your comments of your code, you may give answers to those questions. The precise instructions will be given to you, and as soon as I more know, I will communicate with you via announcements on Brightspace. I will also communicate if you must join with Zoom, and in fact, I probably will you be using Zoom, that you have to join with Zoom. It's better for you because that way you can actually ask the questions. Typically during the examinations, and these are university policies, you really cannot ask questions of help to help you understand something, but you can ask questions in case you think there is a mistake, and then we can fix the mistake and save everybody's time. So in that sense, it's better if we join on Zoom, but I will communicate with you about that. Okay, so that's all I have to say. And don't forget, assignment number 2 is due on Monday. So I think that's all that I have to do with regards to logistics. I have a couple of questions, so let's start with Nehan. Oh, let me allow you to unmute yourself. All right, Nehan, go ahead.
I was just wondering, you know how you said it was going to be based like an assignment? Will we be expected to answer like the same amount of questions, or will it be like
No, it
significantly
will be
less?
less. You're not going to have 12 coding
Okay, yeah.
questions. Okay.
Okay.
Jason?
Yeah, hi. So not 12 coding questions. And so like how many questions do you,
I didn't hear what you said.
so not 12 coding questions. So how many coding questions do you
I
think?
really don't know. Anything that I
Okay.
just that you should be 3 or 4, something that I can, it depends, right? It can be one question that requires more time, like, or it could be 2 or 3 or 4, depending on what I'm asking you to do in a function. It's something that I reasonably can judge that if you did your work in a lab and assignment, you should be able to do in an hour and 20 minutes.
Okay, so and it's not including this lecture, right?
It doesn't include this lecture, no. So no,
Okay.
what we're gonna do in this lecture is so-called slicing, indexing of strings, slicing of strings, loops on the strings, and yeah, so you're not gonna have that.
Okay.
Samir. Nehan, can you put your hand down?
Yeah, so just wondering, like, if you do decide to go the Zoom route, so do you mean it's just like this, where like people are muted and you don't have to show yourself, or?
You mean the camera? You mean do you have to put the camera on?
Yeah, like now, like people that choose don't not to, or like.
Okay, so why is that question important?
Just cause like in general, like right now, I never put my camera on, like.
Okay, but if I ask you to put a camera on, is that, and for you, the fact that I give you that answer right now, yes or no, why is this relevant?
I was just wondering, to be honest, like I wouldn't mind if you asked me now, but I'm just wondering in general.
I really don't know. I honestly don't know if I'm going to ask you to turn, like in a classroom, you show up in a classroom, I see all of you, right? So I don't see, I'm not sure. I didn't decide that yet.
Mm-hmm.
It's an awkward thing for everybody, right?
Mm-hmm. Yeah.
Okay. So, Eshan.
Hi, I was just wondering if sample output's going to be given on the test.
No, because
like
this is the first time I'm doing this type of test. I don't have sample.
Okay.
Oh, sample output, yes.
Yeah.
Yes,
yeah.
yes.
Okay.
Yes. Like in your assignment, yes, because that really helps with understanding it. If you want to be precise, kind of mathematically precise, such that the question is not vague, then it can be difficult to read and parse what is required. And if you're vague, then it's, you know, you may leave something that it's unclear what has to be done. So for that, the examples are very helpful. So you're definitely going to have examples like you did in your assignment. So I'm telling this to everybody. Look at examples. They are often more telling than the text of what you have to do. Yes, you will definitely get examples for what you need to do.
Thank you.
No problem. Ala.
Hello, Professor. I just wanted to know the time frame of the test, which is from noon to 1:30 p.m. Eastern Time Saturday. Does that include the time it's going to take us to save our files and submit them?
That's a very good question. I did not decide. That will be written on the top of the test because it depends. When I write a test, I'll see how much it looks like. So normally it's 1 hour and 20 minutes. So if I deem this is 1 hour 20, 1 hour 15 minutes test, I'll tell you, you have 1 hour 15 minutes to do the test and then 15 minutes to submit. If it looks to me that this is really 1.5 hours for average student, then it's going to be 1.5 hours and you have like 10, 15 minutes to submit. In either case, it's going to say this much you should allocate for your work and here's how much you should allocate for your. So basically it's the question when I'm closing the server. So it's gonna say that. I'm gonna communicate that to you and it's gonna say on the top of the, once I finish the test, I'll know more.
Okay, thank you.
No problem. Okay, Maid.
Hi, Professor. I know they already asked this question, just the content included in this lecture, is it included in the test or no?
No, I already said this.
Yes, I know.
Today and the last time. No,
Yeah.
so you can think of it, what was covered in assignment number 1, assignment number 2, lab 1, 2, 3. So there were no loops, there were no indexing of strings and things like this. And this is what we're going to do today. So you're not going to have that.
Thank you.
No problem. Monica.
Hi there, can you hear me?
Yes, I can hear you.
Okay, cool. So for the test, if we happen to not have enough time to like fully answer one of the questions or however many of the questions like to our best ability, is it better to leave it blank or write an answer even if we're not sure
So
if it's
I would say,
like, is it better to have a wrong answer or a blank answer?
That's a tough one to answer, but let me say this. These are very difficult things to grade for everybody. There's 500 of you. So part of the grading, just like the assignment, will be done by automatic tests. So if your code really doesn't do anything useful, then maybe it's better to double check the rest of it, right? The rest of your, just keep in mind the way it's going to be graded. It's going to be graded test cases, but then the TA is going to look, did you put doc strings? If doc strings are required, are they correct, right? So I would put more emphasis to try to do correctly the questions that I know. And then if you still have time, spend some time solving what you're unsure of.
Okay, perfect. Thank you so much.
No problem. So Mayit, can you put your hand down? Nathan?
Hi, Professor. I had a question regarding like the text file that we usually have to submit with the assignments.
Yes.
Will we also have to test our like code and then submit a text file on like the side?
You mean for the test?
Yeah.
I don't think I'm going to ask you to do that because kind of it's time consuming and I'm not going to ask you, but if you don't test it, if your thing crashes, you're not going to get the points for the function. You better test it yourself. No, but I'm not going to ask you to submit a text file. No.
Okay. Thank you.
No problem. Tony, there's too many questions, guys. I have to teach today. Okay, let's say 2 more minutes and then we start with teaching. So Tony.
Okay, hi, Professor. I'm just wondering if we can only submit the test once or we can put...
It's the same thing. Right before the server closes, you can submit as many, and if you have time, really, why not? Submit as many copies as you want.
Okay, thank you.
Jason, you had your chance. You can ask at the end. Sarah.
Yes. Will you post a mock test for us to practice with?
I know, because this is the first time I'm giving this type of test. Before,
okay, thank you.
Students didn't have a computer during their exams, right? So this is the first time in history that you guys have a computer during your tests. So I don't have any practice tests. Like your assignments and your labs, you can think of them as a practice test.
All right, thank you.
No worries. Sasha? And Sasha is last, then I'm going to start teaching. And then I'm going to stay at the end and you guys can ask me more questions. Sasha?
Hello, can you hear me, Professor?
Yes.
I was just wondering if we have a question that's similar to one of the assignment 1 questions, let's say that we can solve with using if statements or loops, would you like specify whether you'd prefer us to use if statements or in loops, or if
I'm going to specify what you're not. If I say do not use, most likely the test is going to say you cannot use loops, you cannot use lists, you cannot use sets, so the things that you haven't seen, because I want to test that you know what we covered, right? If it's not there, just assume that you can use anything you have seen up until today, okay? And if you're uncertain, I guess you can ask me if we have a Zoom session, or you ask on the Alvin Monitor discussion board and so on. But everything that you have seen up to today, you can use.
All right, thank you, Professor.
Okay, so let's start the lecture, and then when I'm done, you can ask me. You can ask me more. So I'm gonna now mute you all, because remember last time these things happened. That's the only reason I'm. Otherwise, I wouldn't mute you But when you have this many students, currently we have 174 students here, it's very likely that, you pick up a phone and talk to somebody. You forget that you are maybe unmuted. That's why I mute you. Which in a live class doesn't happen, because at least students think she's gonna see me, or, it's kind of more obvious that it's a problem. Okay, so let's start with a lecture today. So what the plan for today is to complete kind of knowledge about what you can do with the strings as a data type, and then learn about loops, a particular type of loop, looping over the characters of a string. So let's go to the Python shell, because at the beginning, I just want to tell you a few more things about strings. In fact, let's actually, I lied, let's go with a few slides to see to remember what we saw the last time. One of the things we saw last time is this super powerful operator in, that allows you to ask a question of the type, is a substring X, is a string X, a substring of a given string S. You can even ask, is a string S not a substring of string S? Okay, I'm going to give you a few more examples of that, and we already saw it in the last class. You have seen before that you can use a plus operator on two strings and then glues the two strings, where it adds glues T to the end of S. You also have seen that you can multiply string S with a positive integer. The result of that is a new string, which has S repeated n times. And you have seen the super useful function len that gives you a number of characters in S. All right, so let's go to shell. And let me give you a few examples. So if you create a string S, let's say it's September. We are at September. It's still September, I think. Oh, there you go. See, these are the things that chat is off. Okay, so so let's say it's September. That's a string that we just created, and we saw this in operator can answer questions of the type, is EP, substring EP, is it in string S, and we get answer true. You can also ask, is it not in string S? Well, the answer is false. It's not true that EP is not in S. So that is, we get a false answer. We also have seen that it is case sensitive. So SEP in S, we're gonna get false because here S is a lowercase. Unlike SEP here in S, we're gonna get true. You can also ask questions such as this one, this is a space character in S, and we get yes, because indeed here between these two S's, we have a space character. And the last one I wanted to show you is about empty string. Remember, this is an empty string. So open single quote, then nothing, then another single quote. This is an empty string. And an empty string is a substring of every string. Okay, so you're gonna get true if you ask this question on any string. Okay, so this is about this in operator. You will see it's really wonderful. You don't really have it in other programming languages. Of course, you can code it yourself. It's basically something called linear search. But this is so convenient, this in operator. You will see, even today, you will see a very cute application of this in operator. So what are the other things that you can do with the strings? You have seen that you can compare numbers, but what about this? If you do something like this, apple less than equal to fig, is this going to crash, or is it going to give some answer? And if you think it's going to give some answer, what do you think it's going to be? Sometimes when I ask this in the classroom, students say that you're going to get false because, you know, maybe you think, okay, apple has more characters than fig, so it shouldn't be that apple is less than fig. Okay, you see here that we get true. So let's understand what it means to compare characters. But let's actually backtrack even more. What does it mean to compare anything? To say that some object A is less than object B, and let's say object B is less than object C, it implies that there is a certain order of objects. Okay, so in terms of number, this order is natural to us. We grew up with this natural order that 1 is less than 2 and 2 is less than 3 and so on. Okay, but in fact, when it comes to strings, there is also a natural order. It's not the one about numbers, like this has 5 characters and this has 3 characters, but there is a natural order on characters, on letters, on alphabet. You have an order, alphabetical order, but in terms of string, this is called lexicographical order. So what does that mean? If in some order you have a word that comes before another word, you would say, if you have a, let's say, string or word A and then another string or word X that come after, you say that X is less than Y. So let's see what it means in text, or what it means for strings, what it means to order them, and what is lexicographical ordering. So basically, think of it, think of lexicographical ordering. So actually, before I even answer that question, just think, if I give you a book of words of a foreign language that you don't know, and I'm asking you, what does the word, find the word, I don't know, this one, and tell me what it means in that language. You would be very annoyed if you start looking through this dictionary and realize that it's not sorted. Okay, so the fact that you can sort something means that there is inherent order to the words. There is something that comes before something else, okay? So lexicographical order, you can just think of it as order that is in dictionary. And for example, word apple in dictionary will come before word fig, okay? So for that reason, when you compare two strings, apple and fig, you are actually doing less than equal does lexicographic comparison. So therefore you get true, because in a dictionary, if you like, or in properly said in lexicographical order, string apple comes before string fig. Okay, so, and in another example that I used to give way back when was one of the phone books. And you guys probably don't even know what the phone books are. They died out probably around the time when you were born. But before cell phones, and right now, for example, I don't even know how would you find somebody's phone, but it used to be that they are kind of public, unless you are, you know, president of a country or some special figure. Your phone, you would only have a home phone, and your phone would be listed with your name in so-called phone book. And once a year, telecommunication companies would give these phone books to every household. So if you want to call me, you would open a phone book for your city and go to Vida Dujmovic and find my number. So of course, these books were super thick, depending of course on the size of the cities. They were based on the cities or regions. They were huge, so of course they need to be, the names were lexicographically ordered. So another way to say it is that it's an order that you would see in a phone book. Okay, so for that reason, hopefully now you understand that why is apple bigger than a fig? You basically start comparing the characters. Character A comes before character F, therefore word apple comes before word fig, so apple is less than fig in terms of string comparison. So let's see a few more examples. Let's see about this one. ATU, is it less than ACTRU? I don't know how I invented these things. The answer is false. So the thing is, you may ask, okay, what if the letters but what if the strings start with the same character? Then you move to the second character. So the way you do lexicographical comparison, to just give you an algorithm, although I'm sure you know, because you know how you would order people's names, let's say by last name. You compare first character of one string with the first character of another string. If they are the same, then you compare second with the second. If they are the same, you compare third and a third. So you do that until you encounter the first pair of characters that are distinct. That determines who comes first, who is smaller. Okay, so in this case, A and A is the same. You move to the next two. T and C are distinct. T should come before C, therefore T is bigger than C, so we get false here. Okay, your next question may be, well, what about this? If you have ATU compared to ATUK, we don't have really two distinct characters. We compare first and first, they are the same. Second and second, they are the same. Third and third, they are the same. And then we run out of characters in the first string. And then the question is, well, which one is smaller? Which one comes before in the alphabet, in the lexicographical order? And in that case, the one with less character actually comes first, okay? So that's why we have true, ATU is less than ATUK. All right. You can also ask if two strings are the same. Let's say this one, sept is sept equal to sept, and you get the answer is true. But this, you're going to get false because Python is case sensitive. Here's another example. Basically, all the characters on your keyboard, all of them are, you can compare all of them. So it's not only letters but it may not really be clear what it means. Hopefully in terms of lexicographical order, this kind of makes sense. This order is kind of meaningful for most all of us, I hope, because you know what it means, the order of last names, for example, how they appear. But the characters are also, the characters such as digits on your keyboard can also be compared. We see that the character 1 comes before character 2, and that's what you would expect. So we are happy about this, but please note that if you follow the algorithm that I told you, this is not like comparing numbers. You're still comparing strings. So here we're gonna get false. And why? Remember, what's the algorithms for comparing strings? You compare first character with the, oh, sorry, that's not with the, that's not the example I want to kill. This one is definitely true. I'm talking about this one. 2 less than equal is 2 less than 12. We're gonna get false. Why? You're comparing first character here with the first character here. They are distinct, therefore they determine the order. So you're actually comparing is 2 less than 1, and the answer is false, and you get false. Okay, here you were comparing 1 and 1, so you cannot draw a conclusion, and then you run out of characters. Well, then the one with less characters wins, so you got true in the previous example. Here's, so some of it may be kind of logical, like this one here. The rest of it, well, it is, this one, it may not be logical if you treat it as a number, but this is really a string. It still follows the logic that, that I explained. Here's something else that you may not guess. What about this one? What about, we said, of course, that B comes after A in the alphabet, so this is false. But what about this? B less than A. Well, to answer that, we need to understand in what order, what comes first? Is it all the lowercase letters first, then all the uppercase letter? Is it the other way around, or is it mixed? Okay, well, it turns out actually that even though B comes in alphabet after A, all the capital letters come before all the lowercase letters. So that's why actually we get true here. Okay, you can even ask things that are kind of nonsensical. Let's say we can ask, is question mark less than the exclamation mark? And we get false. Okay, so basically all the characters that you use in Python, basically there's a total order on all the characters in Python. Some parts of this total order you know naturally. You know that A comes before B, B comes before C, and so on. So some, you know, some parts of this total order, and you know that character 1 should come before character 2, and so on. But you don't know in this partial. Why would you know in this partial order whether question mark comes before exclamation mark or the other way around? Okay, so in this, if you want to find out, so if you think about all the characters, think of all the characters that are on keyboard, for example, they are all associated with a number, and that number, you can think of it, tells you where you are in this order. There is a function to tell you what that number is. I'm just showing you this out of your, just so you know actually that in reality, everything in a computer is represented by numbers, including text. in fact, by binary numbers, so zeros and one, but that's kind of on the side, not exactly what you need now. But if you want to know in a total order of characters, what is the position of a certain character, Python can actually tell you that. There is a function called ord. If you ask it what is the ord, I guess for ordinal, what is the order in the total order of character question mark, it's 63. And then you ask for exclamation mark, it's 33, then certainly 63 is not less than the 33, so you get false. Some of them you can guess once you know the first one. So if you know that the lowercase a is 97, then the lowercase b is run after that is 98, and lowercase c is 99 and stuff like this. For some sort of manipulation with string, actually these things can be useful. Nobody's going to expect you to know exactly the number, these numbers, but I'm just saying this OR function, in some instances, this can be helpful. You don't have to use it, but sometimes you can come up with interesting solutions by using it. All right. So since we are at this, so far you were only using characters, if you like, characters that are on your keyboard, but the characters that you can present and print, for example, in Python are much richer than what you see on your keyboard. First of all, there's a way to literally represent any letter from any language. But not just that. Things like if you want to make a card game, you would like to display a heart and a club and a spade and a diamond, right? So there is a way to display these characters. There are such characters. So the characters that are in your keyboard that existed in a long time ago, there was a limited number of characters that were used in computer. They call ASCII characters. But then these characters have been greatly expanded, and we nowadays have so-called Unicode characters. There is a sea of them. In fact, somebody asked a question, very good question, on the discussion board, noticing that in assignment number 2, my requirements, or the way I display equation is not, for example, if you have 3 times x squared plus 5x plus something, it's not 3x squared. There is actually 3 and then not a star. There is a 3 and then then dot, the real dot that you use in math, not dot like 3.17. 3, then dot in the middle, and then x squared. Okay, so you can find those special characters in these Unicode tables. You can just type Unicode table, but let me show you how you would use it in Python. So here, the way you use it, so for these standard characters that are on your keyboard, you have seen that if you just want to use a character from a keyboard, you just put that character. All right, and it creates a string with that character. But already even with the keyboard, you saw some exceptions that if you want a tab character that you're doing /t, already there was something special about the tab and an enter, new line was like this and so on. So if you want to use Unicode character, you first tell Python by doing /u or \, I'm not sure which one is this. Anyways, this line u is telling Python she is about to give you Unicode character. She wants to use Unicode character. And then each of these Unicode characters has 4 digits. So if you want to use one, you go to one of these tables and find out what are the 4 digits of the character that you're interested in. Because I was coding in the past some card games, I think one of these is a card character, yes. So we get a spade, right? So you do /u, you're telling Python she wants to use a Unicode character, and then then Python expects 4 digits of that character. So here you see I created a string where a character is a spade. Okay, so let's try what comes after that. We have a heart. What comes after that? We have a diamond. Okay, so it looks like there's even 2 versions, the one with colored thing inside and not colored. So actually, control, which was it? Just a second. I don't know what happened here. All right. So actually, if I go backwards here, 59. No, it's some other character. Anyways, you can even just, I was just in previous class coming up with some number. Let's try to see what's this. But as I said, you Google, when you get this, it means there's no character with that number. Let's see, /u 23444. And let's see if this is something. Yeah, this is something. I don't know what, but it's something. Okay, so, and of course, this is just one character. So this is just one character, and you can say blah afterwards. So you created a string, spade, blah. Okay, just one character. Okay, so that's about Unicode. So if you go to discussion board, there is a question there about the multiplication. So you will see, I found what that character, well, it's in my solution for the assignment, what a Unicode character is of that dot operator, not dot operator, or multiplication dot, the one that is in the middle, not down there where decimal place dot is. Okay, let's see if I covered there what I wanted. All right. Okay, so that's all about these comparisons. So let me go back to that string that we started with. So we still have that string. So let me remind you of what a string is. String is a sequence of character. And what I want to emphasize here is a sequence, word sequence. Why? Because we're going to actually see many sequences in Python. Lists or arrays that we're going to do next as sequences. What does it mean to be a sequence? As opposed to a set, for example, or a collection, it implies that there is an order. The order is an important, okay, for this object. I don't mean now order as in apple comes before fig. I mean a different type of order. What do I mean? Here today, that string, T comes before O comes before D, and so on. So these two things like Y, A, D, or T, all right, so these two strings have the same characters, but they're completely different. The order is important, okay? So these are sequence of character. So for everything that is a sequence, it means that there is a first element, second element, third element, and so on until you come to the end. So if you look at this string here, you can ask, because it's a sequence, it's meaningful to ask, was the first character in the string, was the second character, was the last character of the string. For a set, for example, that's not meaningful. If you have a set with some numbers in it, there is no, you can't say which one is the first one, right? So the sets are unordered objects. We're gonna see sets later on. Okay, so the strings are sequences, and because this makes sense to ask what's the first character, second character, and so on, of course that is implemented the way you can ask, give me a first character, give me a second character. The way you do this is the following syntax. If you have a string S, the string that is referred to by variable S, if you want to access a certain character in that string S, you use the name of the variable, in our case is S, and then you open square brackets, close square brackets, and in between these two square brackets, you put a position that you want, so an integer, okay? So if you want a first character, let's say I want to say what's the first character of string S. If you never programmed before in your life, you would think it's like this, that you ask it like this. That's because humans start counting with 1. However, computers start counting for various historical reasons, start counting at 0, okay? So you're gonna get the first character by asking for S of 0, okay? This is so-called indexing. So you're asking what is the character at position or index 0? What is the character at position or index 1, and so on? Okay, so in human language, we would say, what is the first character and that translate to S of 0 in computer language. And that's the case in all the programming languages. So S of 1 is asking for the second character, you get a T. You can ask for the third character, that's S of 2, you get this single quote, and so on. Okay, how would you last? Let's say you don't know the length of S, and you want to ask for the last character. If you want to ask for the first character, it's always S of 0. You don't even need to know the length of the string. What about, how would you ask for the last character? Okay, so we have seen that this function len of S gives us the length of the string. Okay, so you may say, okay, I'm gonna ask, if I want the last character, I should ask S of 14. But remember, the 14th position doesn't exist because we start counting at 0. If the first character is at 0, then the last one is at the length of the string minus 1, is at position 13. Okay, so actually, if you want to get the last, if you don't know the length of a string, so here's how you get the last character. You say, give me whatever is in length of the string minus 1. That's what the last position is. And we get that the last character is R in this string. This previous mistake is very common. It refers to this. These mistakes happen very often. It's telling you string index out of range. What does that mean? Valid indices for this string are 0 to 13. All the other things like 14, 15, if you try to do S of 15, that means that you're trying to access a position that doesn't exist, and you get so-called out of range mistake. Okay, so these are very common. Okay, so let Maid go ahead. Oh, but normally I try not to take the question in class because I go behind. Oh, do you have a question, Maid? You can unmute yourself.
Yes, can we use S index minus 1?
Yes, I'm getting there. That's why, yeah, I'm just getting there.
Okay, sorry. Yeah.
No problem, no problem. Okay, so there's something very nice, and Saeed, I'm gonna take questions at the end because I really wanna make sure we cover the material. So there's something very nice in Python actually, and super useful so if you're using, and I haven't seen it in other programming languages, I don't know if it changed in the meantime. If you use, you use normally positive integers, non-negative integers for indices. So you start at 0, you can start at 0 and go to the end. Okay, so valid indices are from 0 to len of S, where S is your string, minus 1. Okay, but in Python you have something cool that if you want, you can start from the back. You don't have to start from the front. So let's, Aurel, I will take questions at the end. So let's do, let's see, we have the string S. If you start from the back, R would be our first character. So if you use a negative index, negative number, Python starts from the back. You may ask, well, why is this one now not 0? Well, actually, that's kind of logical because this would be, first of all, minus 0. 0 is neither negative or positive, so mathematically it wouldn't make sense. But even more importantly, it would be confusing because 0 and minus 0 are both 0. So do you want me to start from the beginning or from the end? So when you're using negative indices, you start at 1. So R here is in position minus 1. If we do minus 2, we're going to get second from the back. If we do minus 3, we're going to get a third from the back, and so on. You may ask yourself, oh, if I want to go start from the back, how do I get the first character? What index should I use to get a first character? Okay, so I want to use a negative index, but I want you to report I, so the first character. What should I put here? I put len of S, and it's not len of S minus 1 because when we are going from the back, we start counting at 1, right? So we're going to get 1. So you go from 1 to len of s. But because when using positive number, we start from 0, the valid indices are 0 all the way up to including len of s minus 1. Okay, so that is what I wanted to show you about indexing. But now something super cool, I thought it was super cool, actually super powerful. I'll give you an example. One of the most useful, one of the most common searching and one of the most famous sorting algorithms and the most efficient sorting algorithm is actually quicksort. So whenever we were teaching this code in teaching this course in Java, I never could hope to code it during the lecture. It would be way too many lines of code and way too messy. And in Python, thanks to this slicing that I'm going to show you now, it's a thing of beauty, and it's like 4 lines of code. And when we get to recursion, I'm going to teach you that. We're going to implement it. But right now, just to tell you, this is a tool that I haven't seen in other programming languages, unless they have been added in the meantime. It's super powerful, and you're going to see it throughout the semester. So please do make sure that you know slicing. In many ways, slicing is just a generalization of indexing. So what is indexing asking you? It's asking you, give me a substring at this position, starting with this position and ending with this position, right? So S of 0 is saying, give me a character that started at position 0 and ended in position 0, and you get a T. If you are using this syntax, so S, and instead of giving 1 number, you give it 2 numbers. Python is gonna, so you give it 2 numbers where first is second and smaller, so, and separating by a colon. So it's the best to explain it on example. So let's see, I do 5 to 8. Okay, so instead of giving 1 index, 1 number, if I did S of 5, it's gonna give me a 6th character, right? But now I'm giving 2 numbers. Syntax is you separate them by a colon. Okay, so what does this do? It says return all the characters starting at position 5, index 5, going all the way up to 8, not including 8. Please remember that. This is cause of mistakes. Okay, so what does that mean? This means return a new string in S, new string, by going to S at index 5 and return everything up to index 8. So let's try here. 5 is 0, 1, 2, 3, 4. So it looks like 5 is capital S. Then I do 5, E is 6, P is 7, T is 8, but we go up to 8. So if I count it well, this should be SEP. Indeed, this returns SEP. So the first number is where you start, and the last number is what you go up to and not including, okay? So there's basically not much more to tell about this, other than the kind of useful shortcuts. So what would this do, for example, if you do 0, start at the beginning and go up to index 3, let's say. So that's going to return things, the characters at position 0, 1, 2, and not including 3. So what do we have there? I, T, and single quote. And that's what we got here. But if your first number is 0, you can omit it, okay? And you can have syntax like this. All right, that means if you have a colon, but the first digit is missing, this just means start at the beginning, go up to 3. Okay, so it's the same thing. If you omit the second number equally, all right, so if I do, let's say 3 and omit the second number, okay, this is the same as saying start at position 3 and go to the end. All right, so that's what, and what's the position 3? Let's look at 0, 1, 2, 3. Indeed, the lowercase s is at position 3. Okay, so hopefully now you can guess what this does. Omitting the first character, the first number means start at the beginning. Omitting the second character means go to the end. So this just returns a new string, which is a copy of a given string. You go from the beginning to the end. Okay. All right. So this is, so you have seen now two forms. One is you just give one character that's as classical indexing that every programming language has. The other one is that you give two integers separated by colon. And that's where the first integer means, start at this index, and second integer means go up to the second one. And there is a third form where you actually give three numbers. Okay, so what do you think this does? Okay, so we are asking for three numbers. Remember, if I had some number x here and number y, this means starts at index x, go up to index y, and now there is this magical second number. What this means is the skip, meaning give me every second number. So this means start at position x, go all the way up to position y, and return every second character. So not every character. So this 2 is a jump that you are making. So we learned that if you omit the first number and if you omit the second number, that means go from the beginning to the end. And now this third character means, well, give me every second character. So let's look at that. You come here and you see that indeed we have the string s, and we return every second character, capital I, single quote, space, lowercase e, t, m, e, okay? Of course, it doesn't have to be 2, you can ask for every third character. And of course, you don't have to go from the beginning and the end, you can give these 2 digits that we have seen. You can go start at position 2, go to position 10, and return every third character. All right. What do you think this does? So I'm guessing that some of you guessed correctly. This just does a negative jump. So actually, if you start at the beginning, but your jump is negative, that means actually you're going from the back. So this reverses your string. So these things are super useful. But the one of the things that is the most useful and that is used is these efficient algorithms such as quicksort. And in fact, efficient algorithms such as merge sort and so on, is ability to actually ask for the first half, first half of a string. So many efficient algorithms that are out there that you're going to learn in data structure are based on on a principle where you divide a problem into 2 smaller parts, in particular where each part is roughly half the size of the original problem, and then you solve it on these smaller problems. You're going to learn why is that better and how exactly to do this. Completely not obvious. But here's a baby first step. I need to be able to get the first half of the string. Okay, so here's how in Python you can do it trivially. You can just say go from the beginning and return me the first half of the string. Go to the half and you do integer division with 2. This is going to return the first half of the string. Okay, and if I want the second half, I would do, right, start at the beginning, start at half, start at the middle of the string and go to the end. So I'll meet the end, and this gives me the second half of the string. So this is trivial in Python and super useful. Okay, so I think that's all I wanted to show you about indexing. And last thing I'm going to show you about strings before we go to loops is something that's going to follow you throughout. It's kind of a technical things about languages that doesn't have much to do about problem solving, but it causes a lot of program problems when you code. Here it is. If you don't understand, and we're going to slowly get to learn what that means. So you saw that if you assign an integer not an integer, a number, let's say, doesn't matter if it's integer or string. Right now, that variable holds a number, and we can change it. We can give it even a different type. Okay, let's look at the strings. All right, so let's look at a string like this. Today, I created a string, and maybe I think, oh, actually I made a mistake. I really wanted this string to have first letter be capital letter. And you may think, oh, but you just told us how to do indexing. So you can just change it by assigning, saying, make the first character be capital T. Notice that you get a crash. So what I wanted to show you here, that strings are unchangeable. Once you create a string, you cannot change individual characters of the strings. So for now, just start getting used to this, that you need to, eventually you will really have to think, are the objects I'm creating changeable or not? Okay, so strings are not changeable. Programming languages, as I warned you before, have fancy name for basically anything. So for this, instead of calling this unchangeable or inventing more kind of friendly word, the word for that is immutable. I think like this, spell it like this. So strings are immutable, meaning you cannot, once you create a string, you cannot change individual elements of the string. That will not be, for example, the case with the lists. So we're gonna, next week, we're gonna learn about lists. They're called arrays in other languages. You can change individual element of the lists, so lists are changeable. The word for that is mutable. That is going to make a big difference when we get to passing this variable to functions. When you're passing a string to a function, when you pass a list to a function, what you can do with them is very different due to the fact that some can be changed and other cannot. But for now, remember that in Python, some objects cannot be changed once you create it, and some objects can be changed once you create it. Don't confuse the fact that I said that once you create a string, you cannot change the character with this. For example, at the earlier, I created string S, and then I do today, then I do tomorrow. And you can say, well, wait a minute, you just changed the strings. I did not change string today. I just changed what's stored in variable S. These are two completely different things. This string, when it was created, it lives in memory and its individual letters cannot be changed. When we get to this line, please remember always what happens when you see assignment operator. You go to the right-hand side, object on the right-hand side gets created. So new string tomorrow gets created. This string today, nobody touched it. So new string tomorrow gets created and gets stored in this variable S. Okay, that was in fact exactly the same that happened with the numbers. Okay, you cannot, once you create a number, you can equally not change individual characters of the numbers. Okay, so that's what I wanted to tell you for now. Remember that strings are immutable, unchangeable. Individual characters of a string cannot be changed. If you try, you're going to get crash like this. And you will see next week that in case of list, that's not the case. You can change individual elements of a list. Okay, so now let's go to the loops. All right, so I'm going to teach you the for loop. The simplest form of the loop is for loop over the elements of a sequence. Okay, so let's say I create string, what did I call it here? Let me try to use the same thing I used in a previous class. What did I? Okay, CH and I. All right, that's what I used. All right, so here's the syntax of a for loop, and I'm going to explain what it does. So let's say we have some string. You will think that everything is called as. By the way, I can call this anyway, this variable, but I just find it easiest to type S. So let's say we have this string today where we're using this word today. So let me say I create this string today. All right. Let's say that I want to print this string. You know that you can print it like this, right? So what's the big deal? But I changed the problem a little bit and I say, well, actually, I want to print it character by character, one character, then new line, then another character, then new line, and so on. I want to print really character by character. Okay, but then since you saw this, you know, you may be doing this hard coding, it like that, right? But that only works if you see ahead of time what your string is. So what is the solution for this problem? The solution is I want to be able to take characters of a string one by one, have it in some variable, and then print that what's in that variable. That's exactly what for loop does. For loop in particular over the elements of a string or a sequence. So here's the syntax. You have to put a word for, and then I'm going to explain, first I'm going to explain syntax, then I'm going to explain how it works. You have to put a word for, then you put any variable name. So here's a system, variable name. Any one you choose, you have to put in variable name. This variable will be a variable where individual characters will be put in one by one. Then you have to put keyword in. Then you have to put a sequence. Variable that contains a sequence. Why am I saying sequence? Because this same syntax is going to work for other sequences like list and arrays, list/arrays, okay? You ask for this, so it's another variable name. You ask yourself, what do I want to loop over? I want to go loop. What do I want to examine? I want to examine or go through. What do I want to go through? I want to go through character of a string in this case that is stored in variable s, so you put s there. Okay, here you put some variable name. I'm going to put ch because that's a meaningful name for what's going on here. Okay. So now you press enter, notice that Python already, or at least idle, moves the cursor in because everything now that is indented, the same way you had for if statements, everything that is indented after the for loop belongs to the for loop, meaning it's going to be executed over and over, and I'm going to explain what that means. So this for loop is going to take characters in S one by one and store it in ch. So what you want to do is print ch, okay? Just to demonstrate that the body of the for loop, what's inside of the for loop, what for loop repeats, it's not just one line of code. It can be arbitrary complex code. I'm going to add few stars after each letter. Okay. And then outside of the loop, how do you know you're outside of the loop? Again, you look what's lined up with an F, right? It's the code that is not indented in. That is not repeated by the for loop. So just to indicate that, goodbye. Okay, I know I did it fast. For those who are new, I just want to demonstrate what this does, and I'm going to now explain one by one what this does exactly. So let's see that this does what we asked for, what I asked for. Okay, it prints characters one by one with stars in between. Okay, so how does this work? How does loop work? So let me explain what this does exactly. So you have some code, you know what this does. So Python executes this code, goes to the first line, creates a string today. Then it comes to the for loop, okay? First time it encounters a for loop of this kind, what it does is says, okay, I have a string s. I'm going to take, first time I encounter, I'm going to take the first character from s and store it in variable ch. So in our case, the first character is t, so it's going to store a character t inside the variable ch, then it's going to enter and execute the body of the loop. What's the body of the loop? The thing that I just highlighted, everything that is indented in. So what we have stored in ch is where it's letter t, so t will be printed and stars will be printed. So this part is done. So we are now here at the end of the body of the for loop. Whenever Python comes to or any other programming language, when you come to the end of the body of the loop, and that's why it's called the loop, you always go back to the beginning. You always go back to the beginning because you need to figure out, am I done looping? I'm going to tell you how you're going to figure out are we done looping. But you are at the end, you come back here at the beginning. Then Python sees, are there any more characters? In our case, yes. O is there. So it puts the next character in the CH. So second time you come here, it's going to put the second character in CH and enter the loop again. That's why it's called loop. This body will be repeated as long as there are characters in S that we haven't put in CH yet. So second time we enter, O is going to be stored in CH. So O is printed, stars are printed. We are at the end of the for loop. What do? You go back to the beginning of the for loop. Python tests, are there more characters in S? Yes. And what is the next one? D. D gets put in CH and so on. Okay, so let's put this in Python Visualizer so you can see exactly what's going on and how it ends. All right, so it's exactly the same code except that I pick word I because I don't want to go through the loop 5 times. All right, so we visualize execution. For line 1 gets executed. Remember, red line is showing you what's going to get executed next. So this line 1 creates a string I and stores it in variable S. All right. Here's the first time we encounter for loop. What did we say? We have a sequence S, and the first element of that sequence, in our case, character E, gets stored where? In this variable that you named at the beginning, CH. So basically, it's execute. CH is equal to E. That creates variable CH. Okay, so you will see now when I press S, variable CH is created and it has letter E in it. Then we enter the body of the loop and do what it says. Print CH, it's going to print CH, it's going to print stars when I press enter. But now notice that line 4, as promised, since we at end of a for loop, always goes back to the beginning of the loop. So we're going to go back to the, why is it not printing? E stars back to the beginning of the for loop. Python checks, are we at the end? No, there is one more, there is another character Y. So next character Y gets placed in H when you execute this line. So look here and you will see that CH can change to Y. You enter the body of the loop, print whatever is stored in CH, which is Y, then you continue executing the body of the for loop. After the stars are printed, we are at the end of the body of the for loop. And what does Python do? It goes back to the beginning of the loop, goes back to the line 2. It says, give me next character. Next character is E. So you will see when I press enter, E will be stored in CH and we will enter the loop. Print whatever is stored in CH, that is an E. And now we are at the end of the string. And you ask yourself, where is the red line going to move next? Okay, it seems we are at the string, so we might as well move back to the 5. But Python, in fact, doesn't know that yet. It goes back to the beginning of the for loop, and now it figures out, give me a next character, and figures out, oh, there is no next character. So from line 4, now the loop is done. Okay, we processed all the characters. Now it's going to skip the body of the loop and move to the next line, which is line 5, and it's going to print goodbye. Okay, so that's how loops work, at least the simplest form of the loop. So hopefully that was clear. If not, please play with this visualizer. It's extremely helpful. So let's, for the rest of the class, solve for some problem with the loop. Okay, so here we had a code that, so where am I? I wanted to write a function that you give me a string or text, if you like, you give me one string, and I don't want to print all the characters, one by one, I want to print only vowels. So I want to go through the string, whenever I encounter a vowel, I want to print it. Okay, so let's write a function like that. I'm going to call function print vowels. All right. So you ask yourself, well, first we gave it a name, we did that. Then to determine what goes between the parentheses, remember, first you ask yourself, how many values do I expect? And when I describe what your function should do, I said the function takes a string, one string. Okay, so you need one variable, one parameter to capture the string. You can name that variable any way you like. And so just so I don't always use S, let's call it a phrase. So that's going to be a variable that captures a string for which we want to print the vowels. Okay, so before we solve this problem, and it's going to be really quick, let's do a type contract. Again, it is something that, because Python is not strongly typed, it allows you to do mistakes and you don't even know you're doing them. Some of you will see this with assignment number 1. The difference is, even though we covered it a lot, there will still be many assignments where students print instead of return strings and so on. So, and for that, I insist on type contracts, because you have to say what does the function return, the way you actually have to declare in other programming languages. So it's equivalent to the declaration that you do in a function header of other languages. So you ask yourself, what do you expect for a phrase? And I say, I only expect a string. And if you give me a string, I promise I will return what? So let me repeat what I asked that this function should do. The function takes a string and prints every vowel in a string. Did it say that it should return anything? No. So function does something and there is no requirement that it returns anything. So it returns none, because Python returns none if it doesn't encounter return statement. Okay, so we are not returning any value. All right, so now that we have type contract out of the way, again, I can also write a description, prints vowels in the given phrase. Did the given or given? I'm never sure about this. Okay, whatever that article is here. Okay, so whenever you want to solve a problem, please first solve it on a paper. I keep on insisting this, and kind of try to verbalize algorithm steps, specific steps. So how do you solve this problem? If I gave you a string with 200 characters written on a piece of paper, how would you do it? Well, I bet you would look at start at the beginning, you would look at the first character, see, is this a vowel? No, you move to the second character. Is this a vowel? Yes, you write it down. You go to the third character. Is this a vowel? No, you move to the next one. Is this a vowel? Yes, you write it down. So what's the solution? You will go through the characters of the string one by one. For each character, you test if it's a vowel. If it is, you print it. If it's not, you move to the next character. So that's kind of a solution in English. So whenever you hear yourself, I should go through the characters of a string one by one, or I should go through the elements of the list one by one, you should think, what tool in Python allows me to do that? And it's a loop, right? We just saw it. Loops go through the elements, through the characters of a string one by one, and each time it takes a character, it stores it in a variable. Okay, so let's write, we have already seen this. For, I'm gonna again call this variable ch in phrase. So what do we wanna loop over? We wanna loop over a string that is stored in variable phrase. All right, so once I'm inside of it, so what's in ch? It's a character that I'm about to either print or not, depending if they're vowels. So first I have to test if ch, so here I have to determine how do I test is vowel. I need that test, but let's keep that for now, and I leave that for the last step. Okay. All right, so if the test is vowel, if the letter that is stored in this character is vowel, I just print it. That's what the requirement is. Else, what do I have to do if it's not? Well, actually, there's nothing to do. I just want to do the next thing. Well, you can do it like this. Pass means do nothing. Somebody asked me for assignment number 2, what does pass do? Pass means do nothing. You can't leave it like this because Python after colon expects some code. So you can leave it like this, and it's perfectly correct. But in a sense, you really don't need two-way if, so you might as well remove this. That means if the character is not a vowel, we'll end up over here at the end of the loop. So it's going to go back and take an X character. So we are basically done. And once we go through every character of a phrase, let's say there was a requirement that says that you have to print goodbye. Just to show that we are outside of the loop, right? So here's what you do inside of the loop. You test if the character is vowel, and in that case, you print it. Otherwise, program is going to go and take the next character. Okay, so to complete this, how do we test if a character was stored, one character that is stored in a variable ch, how do we test that it is vowel? Well, what are the vowels in English? Except that I'm not sure how exactly to produce. Let me pronounce them not in English because it's easier. What are the vowels? A, E, I, O, U. These are the vowels. And apparently in English, Y is sometimes considered vowel and not. We're going to ignore that. We're going to just test for the five non-complicated vowels. A, E, I, O, U. So if you have to test if CH is one of them, okay? Remember, if you want to test if one of the things is true, you should use OR when you're writing Boolean expression. So we can do this by typing a Boolean expression, say, is CH equal? We've seen now with the comparison operator that you can ask, is CH equal to A? Or is CH equal to A? Or is CH equal AE? Okay, and then we do all of them. Right? What you need is that one of these tests, if one of them give you true, then you vowel, right? So you have to glue them with OR. Remember, you use OR if you want one of them to be true. If you need all of them to be true, you use AND. Anyways, so that's one. This is a classical way to do it, and you would do it like this if you were doing this in Java or C. Okay, so this is one correct solution. But what I wanted to show you is a super cute way that I really liked it first time I saw it. And it demonstrates the ease and the beauty of the SYN operator. You can just add, you've seen the SYN operator and you are just asking, well, is this character H, CH, is it one of these? A, E, I, O, U. You can just ask this, is it one of these? And that's it. Isn't this cute? I loved it first time I see it. Anyways, this works, so let's test that it works. We want to say print vowels in a phrase kiwi, and it prints I, it's working. Print vowels, I don't know, A, E, I, O, U, T, I guess it should print all of them, and it does. Let's go back to this one and do something like this. Well, now really it doesn't print a capital I. We didn't specify that. Capital I is also a vowel, so our solution should account for that. If we go back to that Boolean expression solution, you would just then add more of those. You would add or CH equal A, or, and so on. And in this solution, again, it's super cute. I mean, it's trivial. You just add those. One way to do it is A, E, I, O, U. You can do it like that, and it solves this problem. All right, so you see it now accounts for both capital letters and lowercase letters. But here's a different solution that you use when you are dealing with input from a user. I suggest you use this all the time if you want to do comparisons, because you really don't know are they going to use capitals or not for yeses and nos and things like this. You first turn your string all in lowercase letters. You saw that method. So in fact, you're not turning the string, but that's, so this thing is going to return a new character, which is going to be lowercase, and you're asking that one, is it among the lowercase? So you simply get rid of that problem by turning everything into lowercase first. Well, I guess you can do the same by turning everything into uppercase, but then you're asking here of the uppercase. So here's a third solution for that. It also works. And again, this lower is helpful for your assignment number 2. Okay, so I'm going to stop at this time. Oh, it's exactly on time. So those who would like to ask more questions, I will allow you now to unmute yourself, and the other